Hello everyone. In this lecture I shall discuss the Gauss Legendre quadrature formula or Gauss Legendre integral formula. Now if we recall the Newton-Cotes quadrature formula, we have integral a to b fx dx is summation lambda k fx k. Okay. So that is here lambda 0 f0 plus lambda 1 f1 so on plus lambda n fn. So here we need to find only the value of lambda i's, okay, lambda 0, lambda 1 and so on up to lambda n, because the xk's are equispaced nodes which are predetermined. We need to determine only lambda k, right? Moreover, if we put n is equal to 1, then this Cotes quadrature formula reduces to trapezoidal rule, and which is exact for polynomial of degree 1. Likewise, for n is equal to 2, it reduces to Simpson's 1/3 rule, and this formula is correct up to the polynomial of degree 3. Beyond the polynomial of degree 3, the error is quite high. And similarly, for n is equal to 3, this formula is known as the Simpson's 3/8 rule, and which is also correct up to the polynomial of degree 3. And beyond the polynomial of degree 3, the error is high. And here the limit of integration is a to b. It is arbitrary, right? The limit of integration is a to b. But the Gauss Legendre quadrature rule, what we are going to discuss, the limit of integration will be -1 to 1. However, this method is more accurate. You see, as we discussed, these methods are correct up to the polynomials of degree 1, 3 and 3 respectively, and what we call the degree of precision. However, we can get much closer result integral formula and correct for the polynomials of degree k as high as possible. Okay, as high as possible. The previous methods are restricted to degree 1, 3 and 3, and we make it large, the polynomial of degree k as large as possible. In fact, here k is less than is equal to 2n minus 1, right? K is less than is equal to 2n minus 1, right? And this method is called here Gauss integration formula or Gauss quadrature formula or Gauss Legendre quadrature formula, and subsequently we will read it the Gauss Legendre 1-point rule, 2-point rule, 3-point rule, 4-point rule, 5-point rule, etc. And here we will discuss the Gauss Legendre up to 3-point rule. Okay. So before the details of our discussion, let me to introduce myself. Myself, Professor Susanta Kumar Paikray, currently working as a professor of mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. Okay, so without much delay, let me to discuss the Gauss Legendre 3-point rule. The Gauss Legendre 3-point rule is given by the formula integral -1 to 1. Okay, it is -1 to 1 ft dt is lambda k fx k. That means it is my lambda 0 fx0 plus lambda 1 fx1 so on up to lambda n f of xn. In previous case, here xk, x0, x1, x2 so on, these are all predetermined nodes and equispaced nodes which are known, and we only obtain lambda k. But however, here we have to obtain both lambda I and xi, means we have to find lambda 0, lambda 1, lambda n and x0, x1 so on up to xn, where we have to determine lambda i's and xi's, and the limit of integral should be from -1 to 1, So this is a tragedy that the limit of the integral is -1 to 1. So now we have a transformation. Any integral can be converted to the integral of limit minus 1 to 1, and it is like this. Suppose you are given any integral a to b, right? Fx dx you are given. Now this integral can be converted to a integral here a minus 1 to 1 ft dt. How this can be converted? This can be converted by using a transformation x is equal to b minus a by 2t plus b plus a by 2. Okay, or we may write it, or if you simplify it, here x is equal to a into here 1 minus t plus b into 1 plus t whole divided by 2, or we can make it half, right? We can half it. You take common a, it is half 1 minus t. You take common b, it is half 1 plus t. So you may remember this or this, whatever you like. Okay, so now with this any integral can be converted to minus 1 to 1 ft dt. Afterwards we have the formula summation of k is equal to 0 to n lambda k fx k. So any limit, so this limit a to b here, the limit a to b here is converted to minus 1 to 1. First you convert it, right? X in this implies here t in this, then you apply this formula. Okay, so you have to remember this transformations. Subsequently we will discuss the Gauss Legendre 1 point, 2 point and 3 point rule here. So let we mark it equation 1 say. Okay, so for n is equal to 1, equation 1 reduces to 1 point formula, Gauss Legendre 1 point formula of the form here minus 1 to 1 ft dt is equal to lambda 0 f of x0. So we need to find what is the value of lambda 0. This value of lambda 0 will be here 2 and the value of x0 will be 0. So this formula will be twice f of 0 only. So you have your integral a to b fx dx. First you convert it to minus 1 to 1 ft dt, then this formula is given by this. Okay, this formula is given by this. Then for coming to Gauss Legendre 2 point rule, for n is equal to 2, right? Equation 1 reduces to Gauss Legendre 2 point rule. 2 point rule of the form here minus 1 to 1 ft dt is here lambda 0 fx0 plus lambda 1 fx1. Okay, we need to find the value of lambda 0. The value of lambda 0 will be minus 1 by root 3. The value of lambda 1 will be plus 1 by root 3. And the value of x0 will be, just 1 second, the value of lambda 0 will be 1. The value of lambda 0 will be here 1. And the value of x0 will be, and the value of lambda 1 is also 1. And the value of x0, it is minus of 1 by root over of 3. And value of x1 is, it is plus of 1 by root over of 3. So this formula becomes here 1 into f of minus 1 by root 3 plus 1 into f of plus 1 by root 3. So this is the formula minus 1 to 1 ft dt. If at all we have here a to b fx dx, we can convert it. Okay, so this is the formula for Gauss Legendre 2 point rule. Likewise, for n is equal to 3, equation 1 reduces to Gauss Legendre 3-point formula. 3-point formula of the form minus 1 to 1 ft dt will be equal to lambda 0 f of x0 plus lambda 1 f of x1 plus lambda 2 f of x2. We need to find the value of lambda 0, lambda 1, lambda 2 and x0, x1 and x2. The value of lambda 0 will be here 5 by 9. Value of lambda 1 will be 8 by 9. Value of lambda 2 will be 5 by 9. And the value of x0 will be minus of root over of 3 by 5. And value of x1 is here 0. And value of x2 is here root over of 3 by 5. Consequently, the formula will be integral minus 1 to 1 ft dt will be is equal to 1 by 9 taken common. It is 5 f of minus root over of 3 by 5 plus 8 f of 0 plus 5 f of root over of 3 by 5. Okay. So this is the necessary formula. This is the necessary formula for Gauss Legendre 3-point rule. Now if at all we have a to b fx dx, then we can convert it to this. Okay. So this is what. Now this Gauss Legendre 3-point rule is the basically we use this formula if it is asked to solve the problem by Gauss integral method. Okay, and this is the error here is quite minimized, so we should prefer this one. Subsequently we have also 4.5-point rule, and it is beyond the discussion of the present context. So let us now solve some problems. Now coming to the error in all these methods. Here error is equal to exact integral. We know by your evaluation of definite integral minus numerical integral by these methods integral, and to avoid this negative sign we take the modulus, right? This is my absolute error. Now if this exact integral, if it is not possible to evaluate this integral, definite integral by direct method, not possible by direct method, then we have to use this error formula. So the error formula for Gauss Legendre 1-point rule is, here the error is equal to E is equal to 1 by 3 f of double derivative at the point zeta, and zeta lies in the interval minus 1 to 1. So this is the error formula for your 1-point rule. And the error formula for 2-point rule is, we have a little correction here. Here the formula varies from 0 to n, okay, instead of 1 to n. That's why for 1-point rule, for n is equal to 0, we have one node. Okay, for this is called 1-point formula. For n is equal to 1, right? For n is equal to 1, right? N is equal to 1. We have two nodes here, x0 and x1, and it is 2-point formula. For n is equal to 2 here, n is equal to 2. Okay, we have three nodes, x0, x1, x2, and we have it is our 3-point formula. If we start the summation from 1 to n, then this previous thing is okay. Otherwise, you have to take one less. Okay, so for n is equal to 2, it is 3-point formula. So now the error formula for your 2-point rule is given by error is equal to, it is 1 by 135 f fourth derivative at the point zeta, and zeta lies in between minus 1 and 1. Okay, this is the error formula for 2-point rule. And for 3-point rule, the error formula is 1 by 15750 15750 f sixth derivative at the point zeta minus 1 less than zeta less than 1. Okay, it is 1 by 15750. It should be 15750. So this is the error formula. Usually by direct integral, difference the numerical integral, we take the error. Okay, if the direct integration is not possible, then we use this formula. Okay, let us discuss some problems. So now let us solve one example. The example is use Gauss Legendre 3-point rule to evaluate integral 0 to 1 dx by 1 plus x and estimate the error. Okay, so here you have here integral 0 to 1 dx by 1 plus x, and we need to convert it to minus 1 to 1 ft dt. The first thing is this. Okay, so we have to find it. So you put, as you know, the transformation, put x is equal to half a into 1 minus t plus b into 1 plus t. Okay, so what is my a? So a, this is my a is 0 and my b is 1. Okay, so this is equal to half here 0 plus 1 into 1 plus t, right? So this is equal to here 1 plus t by 2, 1 plus t by 2. So what is my dx now? Dx is half dt. If I want to find what is your t, t is 2x minus 1, right? T is 2x minus 1. You may use this or you may use this, whatever you recall. X is equal to b minus a by 2t plus b plus a by 2, whatever formula you recall. So this will be b minus a, b is here 1, so 1 by 2t, and it is here plus 1 by 2, right? It is here t plus 1 by 2. So you may remember this or this, whichever is convenient, you can do that. Okay, so now this integral, so therefore, so this implies my integral 0 to 1 dx by 1 plus x becomes, and no need to check it by default. You see, if at all you want to check it, so no need to check. However, if you want to check it, for x is equal to 0 implies t is equal to minus 1. You see, for x is equal to 1 implies t is equal to here 1. So no need to check. It is by default minus 1 to 1. Here dx is half dt divided by 1 plus x is 1 plus t by 2. So this is equal to 1 by here 3 plus t dt minus 1 to 1. Now this is my ft. Okay, now this is here minus 1 to 1 ft dt with ft, where ft is equal to 1 by 3 plus t. Then we have here, we have Gauss Legendre 3-point rule. The formula is integral minus 1 to 1 ft dt is here 1 by 9 5 f of minus of root over of 3 by 5 plus 8 f of 0 plus 5 f of root over of 3 by 5. Okay, now this is your ft and we just simplify it. So this is equal to 1 by 9 here 5 into 1 by 3 minus root over of 3 by 5 plus 8 into 1 by 0 plus 3 plus 5 into 1 by 3 plus root over of 3 by 5. Okay, so if you simplify it, it will give you 131 by 189. This is equal to 0.693122. Right, this is numerical. Now this integral is 0 to 1 dx by 1 plus x is this is our numerical result, right? So this is, I can say, I numerical. I numerical, right? I numerical. If I find I exact, what is my exact integration to find the error? It is 0 to 1 dx by 1 plus x is ln 1 plus x. Here 0 to 1, this is equal to ln 2 minus ln 1. This is ln 2 minus 0. This is equal to your ln 2. The value of ln 2 is here 0.693147. So if you want to find the error, so this minus this, okay, this is the larger one. So I numerical minus I exact, okay, I exact minus I numerical. So 0.693147 minus 0.693122. So this is equal to 0.000025. You see, the error is quite less, okay. If we want to find up to 4 significant digits, then the error is 0. Now let us solve one more example. Now coming to one more example. Use Gauss Legendre 1 point, 2 point and 3 point rule to evaluate this and estimate the error in each case. Okay, now coming to the solution. Now you have here integral 1 to 2 2x by 1 plus x fourth dx. First we need to find it minus 1 to 1 ft dt. So this is our first job. Okay, so how to get it? You put the transformation, put x is equal to half a into 1 minus t plus b into 1 plus t. Okay, so here a is equal to 1, so this is half 1 into 1 minus t plus 2 into 1 plus t, right? So this is equal to 1 by 2, it is 1 minus t plus 2 plus 2t. So this is 1 by 2, here 3 plus t, okay, 3 plus t. If I want to find what is my dx, dx is here half dt. If I want to find what is the value of t, t is 2x minus 3. So now my x, this is my x, okay, this is my x, this is my dx. So therefore my integral 1 to 2 2x by 1 plus x fourth dx becomes, by default no need to check, it is minus 1 to 1, twice the value of x is 3 plus t by 2 and dx is here half dt divided by the denominator is here, the denominator here is here 1 plus x fourth, it is 1 plus x fourth 3 plus t by 2 whole to the power 4. Okay, if you simplify it, it is here minus 1 to 1, it is here minus 1 to 1, 1 2 remains here and it is 16, it becomes here 8. So it is 8 into t plus 3 dt, it becomes here 16 plus 3 plus t whole fourth. Okay, so this is my ft now. So this is minus 1 to 1 ft dt. Okay, where your ft is equal to 8 into t plus 3 divided by 16 plus 3 plus t whole to the power 4. Now we apply the Gauss Legendre. What is your direct integration? Also your direct integration is integral 1 to 2 2x by 1 plus x fourth dx. If you integrate it directly, it will be tan inverse 4 minus pi by 4 and the value is 0.5404. Okay, now here Gauss Legendre 1 point formula. Here integral minus 1 to 1 ft dt becomes here twice f of 0. Okay, so this is equal to twice, putting here t is equal to 0 here, it is twice 24 divided by 16 plus 81 is equal to 0.49 48. If we want to estimate the error at this stage, so this is my exact value and this is my approximate value. So subtracting this, we have error at this stage. We have error at this stage is 0.5404 minus 0.4948. It is 0.0456. The error is higher. Now if you have your Gauss Legendre 2-point rule, here minus 1 to 1 ft dt is equal to 1 into f of minus 1 by root 3 plus 1 into f of 1 by root 3. Okay, if you simplify it, it will 0.3842 plus 0.1592, and this is your 0.5434. And if we want to estimate the error, this is numerical integration minus the actual integrations, and the error here will be 0.5434 minus 0.5404, so it is 0.003. Somehow the error is manageable. Now coming to your Gauss Legendre 3-point rule. The formula here is minus 1 to 1 ft dt is 1 by 9 5 f of minus root over 3 by 5 plus 8 f of 0 plus 5 f of root over of 3 by 5. If you simplify it, it will give you 1 by 9 5 into 0.4393 plus 8 into 0.2474 plus 5 into 0.1379. Okay, and if you simplify it, it is 0.5406. Now what is your error? So this is numerical value and this is your direct value. So the error here is 0.5406 minus 0.5404. So this is 0.0002. You see, the error is quite minimized. So if it is asked solve by Gauss Legendre rule, undoubtedly we should apply the Gauss Legendre 3-point rule. Okay, so with this we should conclude. Before I conclude, my appeal to all of you is that if you feel that this lecture is useful and interesting for you, please like and subscribe to this channel, and which will boost my motivation to upload subsequent lectures for your benefit. Thank you all. Have a nice day.